Okay, we are at the, I guess, 9 o'clock hour, SL time. Should I go ahead and get started? Cool, great. All right. Let me tee up my presentation here on the slide. Oh, okay. I will wait for the stream. Okay, perfect. Let me see. I'll get my slides up here and we'll jump into it. Okay, cool. And we'll start here. Like I said, I got my speak easy, so slide 1. Hello, everyone, and welcome. I'm Ben Fulcher from Lindenwood University's Game Design Department. That is in St. Charles, Missouri, just outside of St. Louis. And today I want to talk about something counterintuitive. And this is how games designed to make you fail can teach us about, let me pull up my text box here, about how people learn. So the title is Failing Forward, Insights from Difficult Games. And in the games I'll discuss, failure isn't just something you avoid, it's inevitable, and it's something you learn from. It's how you get better. So let's dive in. And again, thank you all for being here. Okay, so slide 2. Here's the central question. What can difficult games teach us about learning? I want to introduce 3 core games that model effective learning in ways traditional education often doesn't. Some of you might already recognize some of these games. First is Dark Souls. And if you've heard of it, you probably know its reputation. It's brutally hard. You died becomes a constant companion. And there's a meme that states, you don't win, you just do a little better each time. But here's the thing. Dark Souls also teaches persistence and resilience. Every death teaches you something. And the game baits players into traps, forcing the player to take every corner with caution, but only after being blindsided by hidden enemies, several times most likely. The game doesn't get easier, though. You just get better. The second game I want to talk about is Getting Over It with Bfulche. You're a man in a cauldron climbing a mountain with a hammer. It's a tale as old as time. It sounds absurd because it is, and there's a narrative aspect of the game that talks about getting over the breakup of a long relationship. So that's kind of some of the subtext here. But it's a meditation on frustration. You can lose hours of progress in seconds. The game forces you to sit with discomfort rather than avoid it. It teaches you to embrace frustration as part of growth, and it also requires patience, forcing players to slow down and really think about their actions. And the third game I want to highlight is Project Zomboid. This is a zombie survival game with permadeath. And before you begin playing every play session, the player is reminded this is how you died. You have to click past the screen before you can actually jump into the gameplay. And this is a statement that players are reminded constantly. Failure is inevitable. So once your player succumbs to the undead, they become part of the horde, and any experience points gained is lost forever. When you die, you lose everything. Except you don't really. Each run, you expand your map, you learn the systems, you develop strategies, you nest away goods in a safe house for future survivors. Your knowledge persists even when your character doesn't, and it teaches progression through iteration. These games are punishing, they're frustrating, and millions of people still love them. And so why is that? Because they figured out something about how humans learn. Next slide. So what is the core insight for this whole presentation? Really, it's that failure is your friend. And this might sound like a motivational poster, but I mean it mechanically when we think about structures and systems. So every setback prompts reflection and adaptation. You don't just die, you think about why you died and how not to. You shouldn't have tried that boss without all of your Estus flats. Or maybe, you just got too comfortable ransacking an empty mall to notice the lone zombie laying in the corner of the bookstore. It happens all the time. Maybe next time you'll keep an extra pair of flashlight batteries. Struggle, when well designed, builds mastery. The difficulty isn't arbitrary in these games. It's very purposeful and intentional. And the confidence you build extends beyond the screen. So this connects to real life research as well. Manu Kapoor's work on productive failure shows that students who struggle before being taught actually learn much more deeply. And Carol Dweck's growth mindset research shows that how we frame challenges matters. So when we see ability as developing through effort, we approach failure differently. We approach it with a more open mind. Ownership of effort in progress is more meaningful when it feels earned. These games have internalized these principles, often more effectively than our classrooms have. So let me show you the basic structure that makes this work. I call it the failure forward loop, and it has 4 stages, as you can tell in the slides. So the first phase is attempting. You try something, you experiment with a new magic build in Elden Ring, or maybe you're trying a new writing style for a creative essay. Step 2 is failure. It will happen. It's inevitable. Maybe not every single time we approach something, but it does happen. This is where you learn what didn't work. Maybe a fantasy voice wasn't great for that creative essay about jazz, or maybe your fireballs were too slow for Godwin the Golden. So the third stage, you analyze. You reflect on why that fireball spell is so slow. And then finally, you adapt. You adjust your approach. Yes, that fireball spell is slow, but maybe a sorcery might be a better approach. Then you loop back to attempt, and the cycle starts over again. So in games, this looks like die, respawn, and try a new strategy. In education, it should look like submit, get feedback, and then revise the work. But here's the problem. In many classrooms, that loop is broken. Students submit something, they get a grade, and they move on. There's oftentimes no response. There's oftentimes no option to iterate, and failure is terminal. It's not very formative. It doesn't tell the learner anything about what didn't work. If a player fails, however, they're usually immediately thrown back into the action to try again. Hello, I am back. Can you all hear me? Okay, great. Apologies for that. It seems like my free premium trial went out. Yes, SL is excellent for teaching through failure. Okay, let me pull up my slides. Oh man, I'm gonna have to click through all these real quick. Thank you all for your patience. All right, I am on slide 4. I'm getting there. Thank God it was early on. Okay, so where was I now? Okay, so if players fail, they're usually immediately thrown back into the action to try again. And that's what games do well to make this loop fast, or the games that do this well make the loop fast, they make it low stakes and continuous. And that's what we should aim for when teaching. Okay, so slide 5. Who gets to fail safely? And this is, before I go further, something that does need to be addressed. This is really important. Failure carries different weight for different learners. Who we talk to, or when we talk about the failure forward, we have to ask who gets to fail safely. Not all students experience failure as psychologically safe. Not all learners do either. For some, first-generation students, those with imposter syndrome, students unsure about their abilities, failure feels existential. It's not just, I failed this assignment, it's maybe I don't belong here, or this isn't for me, or I can't do this. In games, players self-select into difficulty. Nobody is forced to play Dark Souls, and when you get frustrated with a game, you can turn it off at any point. In our classes, that motivated self-selection doesn't always exist. So how do I handle this in my own classes? First, I recognize that no teaching approach is one size fits all. Some students are visual learners, others are readers, some prefer to listen to information, and some can only understand with hands-on experience. I am one of those people. Not to include the impact of background, race, class, and access. And this is why one-on-one support is so essential. I build in individual check-ins in all of my courses. When a student struggles, I help them find a path forward. I let them know that it is okay to struggle, and I am here to help. And third, I use low-stakes early cycles to build safety. The first prototype isn't make or break, it's just practice. And this practice is a thread through all of my courses. From introductory courses, students build card and board games in 3-week sprints with time to reiterate in the final week of the course. Students continue these weekly sprints throughout the program, emphasizing experimentation and rapid iteration. Fourth, I celebrate iteration, oftentimes more than the actual outcomes themselves. Again, it's more important to experiment and break the tools than fear them. Your first try will never be perfect, but you have to start somewhere. You see a quote on screen from a student who felt overwhelmed by one of my courses that has a weekly sprint pace, which I'll highlight here shortly. And the quote is, "Given that I only have a week to make something from scratch, it just seems too much for me." And that's totally valid. My job is to help them through it, not dismiss their concerns. Individual support is the backbone that transforms failure forward from philosophy to practice. And this is something that I put a lot of pride in doing weekly and daily. So the next slide, let me show you how this looks in practice. So I teach a course called Prototype Studio, and this is what the previous quote was from. It's an 8-week course with 1-week iteration cycles. Week 1 through 6, students develop a new prototype based on a provided prompt each week. And every single week, students make something new from scratch. In addition, students are introduced to a new game engine with demos and documentation. And by week 7, students revise a project. This is revision week. Students go back to a previous prototype and improve it based on feedback from their peers and from their professor, me. In week 8, peers review that final prototype and they reflect. Students review a random selection of 3 games from the course, providing detailed written feedback and a completed, non-graded rubric. The weekly rhythm: Monday, I introduce a new prompt and showcase a new game engine. Tuesday through Friday, students develop their prototype. And over the weekend, submission and peer discussion. Then we start over. This sounds intense, and it absolutely is. But here's what happens. By week 3 or 4, students stop being precious about their work. They know another prototype is coming. They're not afraid to try something weird, because if it fails, they'll make something new next week. The focus is more on the research and problem solving than it ever is the finished game. And this is common in a lot of my coursework. The weekly cycle creates low stakes failure by design. So week 7, revision week, this is crucial. That's where students practice the adapt part of the loop. They take feedback and make something better. Revision isn't extra credit, it is required. Just like getting good in Dark Souls is a necessity, not an option. You see a student quote about being forced to try a different game engine. That word forced is really interesting. The quote is, "I appreciate being forced into trying a bunch of different engines I might not have otherwise tried. I genuinely feel like both my skills and enthusiasm for game design have grown." The structure pushes students outside of their comfort zone, and they're grateful for it once everything is done. Maybe not during class. So the next slide. Prototype Studio is about individual iteration, but game development is usually collaborative. So I also teach a course called Team Studio, where students work in small teams of 4 to 6, and there are usually 2 to 3 teams per class. This is also 8 weeks, but with 4-week sprint cycles instead of weekly cycles. Sprint 1, you have team formation. Students are introduced to themselves, they get to know each other. And then we have development. Students work on their projects, and then they submit and critique. Sprint 2, students either revise project 1 or start a new project 2. And then they repeat the same process and have their final submission in week 8. Students have a choice in Sprint 2. They can iterate on their first project, or they can start fresh. Either way, they're applying what they learned in the first half of the course to make better work. Some key features that make this work: it's genuinely collaborative. Teams share stake in one project. They must also find time to communicate weekly and collaborate, almost always online. We use version control, GitHub specifically, to mirror real-world workflows. This also introduces students to industry tools and expectations. There are formal critique cycles after each sprint. For synchronous courses, students are required to give brief presentations about their work. This might take form of in-person presentations in class or virtual presentations through Teams. Students build peer networks and communicate skills. The student quote on screen connects classroom structure to real-world practice, and that is the ultimate goal. So the quote is, "Weekly goals really put us on track to effectively use the 8 weeks in Team Studio 1, to be put into practice when doing the real deal outside of college." Okay, slide 8. So does this actually work? Let me share a little bit of data. I run entrance and exit surveys asking students to rate their confidence on 15 game design skills. This is specifically in the Prototype Studio course. They use a 5-point scale from not at all confident to extremely confident. The numbers you see represent students who rated themselves very or extremely confident. This is a 4 or a 5. So these are the top 2 levels. And if you look at these gains, proficiency in time-based elements from 13% at entrance to 81% at exit, and that's a 68-point jump. Ability to iterate based on feedback from 22 to 77%. Rapid prototyping, just 4% felt confident at the start. By the end, it was 58%. Now, I want to be clear about this data and what it is and is not. This is self-reported confidence, not objective skill measurement. And this is not a controlled study. There's no comparison group. The sample sizes are modest as well. So 23 at the entrance exam, 21 at the exit. I had 2 students who dropped out of the course. But the consistency of these gains across different skills and cohorts suggests something real is actually happening. Students aren't just learning, they're recognizing their own growth, even if it's just anecdotal. And this confidence shows in sequential courses. Students come into upper level courses more confident and capable. Okay, so slide 9. Now I teach game design, but these principles aren't limited to my field. Let me show you how mechanics from these games apply to other disciplines as well. Dark Souls is punishing but fair. Every death is your fault, and the rules are consistent. In math, this might translate to problem sets with unlimited attempts. Students retry until mastery. Getting over it with Bfulche has no save points. You can lose all of your progress in a matter of seconds. In writing, this might look like draft workshops where students read rough work aloud. Discomfort is part of growth, not something to skip or avoid. Embracing discomfort will grow confidence. Project Zomboid has permadeath with persistence. You die, but your knowledge carries forward. In the sciences, this means lab experiments where failed trials inform the next hypothesis. Failed experiments are data, not dead end. The pattern is consistent. Embrace failure as information and make the feedback loop fast. Trust that persistence leads to mastery. And slide 10. Let me distill this into 5 actionable insights just to drill this down a little bit further. 1, normalize failure early. Frame first attempts as expected to be imperfect. Rough drafts and messy prototypes are part of the process. 2, build in reflection points. After each attempt, ask explicitly, what worked? What did not work? How do you improve? Don't assume reflection happens automatically. You have to structure it in. 3, require iteration, not just submission. Design at least one mandatory revision cycle into every major project. 4, celebrate progress, not outcomes. Recognize growth in iteration. Improvement deserves credit. And 5, provide individual support. There's no one-size-fits-all approach. Build in one-on-one checkpoints for everyone. Some students need more scaffolding to fail safely, and that's not weakness. That's just good teaching. And my final slide, I want to leave you with this. You don't start Dark Souls with a nameless king. You don't start getting over it at the anvil. And you don't start Project Zomboid in Louisville. If you know these games, you know what I mean. These are the hardest challenges faced after hours and hours of preparation. The Nameless King is one of the most notorious boss fights in the entire series of Dark Souls games. Getting over its anvil is the most frustrating obstacle in the game and is a major choke point. And Project Zomboid's Louisville has the highest density of zombies in the game and is almost certainly a death sentence. Good difficulty is scaffolded, and so is good teaching. These games don't throw you into the hardest content on day one. They build, they teach, and they prepare you. Then, when you're ready, they challenge you, and that's what our classrooms should do. Difficult games work because they're fair, they're visible, they're flexible, and they're beatable. So they're fair because the rules are consistent. When you fail, it's clear why. They're visible because you can see progress even in failure. And they're flexible because they offer multiple approaches that work. You have agency. And they're beatable because mastery is possible. Others have done it. The system doesn't change, only you do by getting better. And the best classrooms are the same. Thank you all for your time. Again, I'm Ben Fulcher. My email is on the screen, and I'm happy to connect with anyone after the session. And I'd love to open it up for questions. Okay, Letty just asked, how do I assess progress? Um, this is really tricky because, like I said, every student requires kind of individual feedback and individual attention. In my program, not every student comes in with the same background. I have some students who have made 20 games before they start their first course. I have some students who make it halfway through the program and have not opened up Unity or Unreal yet. So progress is difficult to measure, and that's where meeting one-on-one with students, working with them to help troubleshoot, either during weekly office hours or set up one-on-one meetings, is really valuable. So a lot of times I will look at, where did a student start and where did they end? For classes like my prototype studio course, where they're making iterative projects over like 6 weeks, I go back and look at projects during week 1, week 2, and week 3. And then I look back at, I will do that, Beth. I look back at, what did they turn in towards the end of the course? Oftentimes in that class specifically, because they are forced to revise a project in week 7, that can often be a good indicator of progress. Let's see. Merlin asks, are you explicit in the beginning of the course about failure as a learning experience and the importance of getting outside your comfort zone for learning to take place? That's such a different attitude towards learning that students are probably used to. I mention that anytime anyone will listen. I have been developing games since 2017. And it's something that I constantly butt into, especially when you're working in any kind of digital technology. Updates change things every single day. So something that you might be comfortable with today might be obsolete tomorrow. And understanding that frustration and failure and just hitting brick walls is part of the process, and that is something, the process itself is something to be celebrated, is a big kind of like paradigm shift for a lot of students. But once you encourage them to say, hey, I just taught a Team Studio One class. I just finished it up about 2 weeks ago. And in that class, every single week I was telling students, hey, if you're uncomfortable with GitHub or working with a team, that's okay. Just get in there and break it. And that's what I tell students all the time. Get into Unreal, get into Unity, break it, press all the buttons. If you make a project that just explodes, that's okay. You can always make a new project. That is something that I do really push forward and tell them, because so many students are afraid to fail so much that they're afraid to do the actual work. Have your students ever played Souls games and understand the analogy for your course? Do you use this analogy in the curriculum? I use this analogy a lot. Not all of my students play like Dark Souls or the Souls games. I play them, and playing those games really, I started with Dark Souls 3. I played all the Dark Souls and Elden Ring and Bloodborne. I still haven't beat Sekiro yet. Those games really changed my mindset on approaching not just how I played video games, but how I approach problems in real life. So that is an analogy that I bring up a lot in my own class. Let's see. Hearing about it up front is scary, but the experience is probably like the games, challenging but ultimately empowering. Yeah, absolutely. And you can see that in some of those quotes where students felt forced and pushed out of their comfort zone. But again, once you get halfway through this process, once you've made a few prototypes, once you've worked in a team and have these 1 week kind of sprint cycles, students get comfortable with that. And they get accustomed to, okay, well, not every solution is going to be the right one. And it does become kind of encouraging, like, hey, I messed this up, but let's try a different solution. I think this productive failure is a great process. And now that AI is tempting students into offloading their cognitive process to AI, I think that's a really good point too. And that's something that I touch on with my students. So our program is design centric, so not development focused, game design focused, meaning it's more about the idea and the concept of the project, more so than the technical development, which is critically important too. But with AI, I encourage students to use it as a iteration tool, but don't ever count on it giving you the final answer. And a lot of times through my own work, I've found that working with AI can be just as frustrating as just doing the research yourself online. And it's really understanding about where your own knowledge is limited and what you're getting AI to fill in the gaps for. And if you can't check that knowledge, then you don't know if it's right or wrong. that's kind of another conversation, I think. But let's see. You can feel punished for playing a game, and then when you accomplish that boss, like Millicent in Elden Ring, the emotional feeling is amazing. Yeah, and if you had help, that feeling is pretty amazing. How the random person really helped you in the working collaborative efforts leave a positive feeling too. That is, Chandra, that is a really good point. And again, that's something that I point out to my students. Like, as much frustration as you feel, if you keep pushing through that, whenever you finally achieve that victory, and again, I compare it to Dark Souls all the time in my classes. Like, yeah, you might bust your head against a boss 50, 60 tries, and it will be frustrating as hell, and it might take you a week. But when you finally do beat that boss, there's no kind of like substitute for that feeling of elation and catharsis. I call it the nerd shakes because that's what I get. But it's this like uncontrollable feeling. And frustration is an understatement, but I encourage students to lean into frustration and discomfort. It's just like, it's not just video games, it's public speaking, it's getting in front of a crowd and talking to people. Some students don't feel comfortable doing that. And having courses where students have to present in front of a small group of their peers, it's kind of like opening up the floodgates and getting them accustomed to these things. And it's just like, encouraging failure and difficulty and leaning into it. None of this has directly been published, but that is something that I am working on. And that's why I'm presenting today. This is all part of a larger research that I'm working on. If anyone's interested, my email is up here. I'm happy to share any information or any publication links once those are posted. I'm also happy to share any kind of like student work or things like that, or other ideas. I feel like this is where we really need to change student expectations for learning. Doing the work is where the learning takes place, not in the lectures. I absolutely believe that wholeheartedly. My undergraduate background is in fine arts. I've had a focus in drawing, and what I learned there was so much of process. And my master's degree is in animation, and so much of animation is process too. I think I try and bring up the parallel that a 10-second animation doesn't take 10 seconds to make. A 10-second animation probably takes like 10 days at the very least, but probably closer to 10 weeks. If you're talking about Disney quality, if you're watching an hour and a half Disney film or Pixar film, like a high quality animated film, 10 seconds of that will probably be about 10 months of work by a team of at least 20 plus people. So much of the process gets overlooked, and I find that is where you do learn the most, especially with difficult, like multifaceted tasks, like creating a game, for instance. But it's anything too, whether it's writing a research paper or creating an animation or developing an app or solving a math problem, right? Process is so important, and I think it gets overlooked for the sake of the outcome. Yeah, and there are definitely, I highlighted 3 games today, but there are no shortage of difficult games, especially when you start looking at like difficulty levels and being able to adjust those. Um, I think there's a lot of really good things happening in games, not even just difficult games, but games teach people how to learn. And every single game you turn on and boot up the first time you play it, you're learning an entirely new system. But all of these games are engaging and they make learning fun. They make failure fun. And I think that is kind of really the core takeaway from a lot of my work in just teaching game design and playing games. Yeah, like I said, I'm happy to share kind of any other information. If you want to kind of message me or DM me, my email is also up here. I'm pretty good about answering this frequently. But please, if there are any questions, I'm happy to answer further. Yeah. Well, thank you all very much. Like I said, I appreciate everyone coming out, and thanks for having me be involved as a presenter. This was a great experience. This is my first time in Second Life, and so this has been a truly learning experience for me.